Hey guys, in today's video we'll be doing another portfolio project. So this time it's SQL and Power BI. So I have a data set here that we will clean and analyze using my SQL workbench, and then we'll visualize our results using Power BI. So the first thing we're going to do is create our database. So you'll just do create database projects. You can call yours whatever you like. Mine will be called projects. Then you run that, and then here on the left side you just refresh and it appears. So after creating your database, you don't yet have a table where our data will be stored. So you'll expand projects, and then you right click on tables and select table data import wizard. So you'll browse to the place where you've stored your data set. So the dataset will be linked in the description, so you can either download it from my GitHub account or you can download it from my Telegram group. So after selecting your dataset, for this section you have to make sure the database selected is projects or whatever you've named yours, and then here on human resources we'll replace that with HR. It's just short and easier to work with, and then we'll click on next. So in this section, this is now, it shows you like a little sneak peek of the data set. So we are not going to change anything, because if you try to change the data types, you might end up not importing all of your data. So the data types here have to be the exact same as those that are in your CSV file. So you'll just leave it as is and select next. Then this part will select next and it will start importing. So this importing process, it usually takes a bit of time. So as you wait for that to finish importing, I'll just take you guys through the data set so that you can understand what it's about. The first column is the ID, which I'm assuming is the employee ID, then the names, the birth date, the gender, race, department, job title, location, the hire date, and then the term date. The term date is the termination date. So it could either be the employee was terminated or fired, or the employee quit. So what it basically means is that the employee doesn't work there anymore. So that's the termination date. Then there's the location city and the location state. So when you look at this, most of these columns, they have to be text except for the dates. So that is the birth date, the hire date, and the term date. So when we look at birth date, we can see that the data types are mixed. So there are some which are date, others which are text, and also it's just the formatting is not consistent. Some have a forward slash, others have a hyphen. So the case is the same with the hire dates. So this, you are going to change them back to the correct formatting, MySQL, and then you can see the term date, it has also like missing values, and the date is also mixed with the time. So this time is not going to really be useful to us in any way in our analysis. So during our cleaning process, we are going to remove it. Those people whose term date is missing, it means that they are still employees in the company. So for those employees whose term date has a value, it means they've been terminated. But when you look at this data set, you can see it has a lot of values. Some of them are in the future. Like for this first value, there's 2029, which is not possible, because if you've been fired, you are fired like either today or on a date before today. So it's not possible for you to have been fired in the future. So unless this maybe is like a contract, but I'll show you how we'll deal with those values during our analysis. This is how it will look like when it's done. So we'll click on next, and then it shows you 22,214 records imported, and the table HR was created. So when you're importing your data set into your database, you can also choose to create the table beforehand, but I think this is usually, I prefer this way better, because you'll just leave the data types as is, and then you can change them up later when you're doing your data cleaning. So you'll click on finish, and that's it. So The next thing you're going to do is just at least view a sample of our data. Before we start using our database, we have to tell MySQL that we want to use that specific database, because there are also other databases here in MySQL Workbench. So we'll just say use and then the name of your database, which is projects, and then you run that. So it will know any queries you run, you are trying to query the projects database. So after that, we're going to view a sample of our data. So we'll do select all from HR. When we looked at the data previously in Excel, the ID was just ID, but now that it's been imported into my SQL Workbench, we are able to see how it was really like saved. So you can see it has some special characters and then ID. So we are going to rename that later. And then the birth date, you can see they are still like mixed formatting and all that. Yeah, so you can see this is the exact same data we were looking at in our Excel sheet. Yeah, so the data has been imported successfully. So the next thing we are going to do is actually start our data cleaning. So the first thing we're going to do is we are going to rename our ID column to employee ID. As you can see here, the way it has been saved is not really convenient if you try to query anything using that column. So we're going to rename it. So we are going to use the alter table command. So we'll alter table. Our table is called HR, and then we do change column, then this column. So I'll just copy it from here on the side, then paste it in to make sure I've captured it correctly. And then now the new name for our column, it will be employee ID. Then you give it a data type. So we'll do a varchar. It has, I think, about 10, so we'll just put 20 just to be on the safe side, and then a constraint, so it's null. And then we'll run that and it will change. So yeah, it has executed successfully. So when we again display the table, you're able to see that it has changed to employee ID. So for it to reflect on this side, you just refresh here on the left. You can see employee ID, it's varchar 20. Yeah, and then now the next thing we're going to do is actually check the data types for all our columns. So you can use describe HR and it gives you the exact same output. We'll start with changing the birth date from text to a date. So you have to change the values in that column. We can see that the formatting is mixed, and SQL it recognizes it as text, which means not all dates have been formatted as a date, and we need to change that. 6 is the month, and then 29 is the day, and then 1984 is the year. So if a value in this column has a forward slash, we assume it has been saved in that exact format, and we convert it using the string to date function. So that function will basically convert this value into a date from text, and then we're going to use the date format function to convert it into the SQL date format, which is the year, month, and day. So, and then after that, we're going now to check for values that have a hyphen. If the date value has a hyphen, we assume it is also in the exact same format. You're going to write that code. So what you have to do is update your table. So we'll update HR, and then you'll set our birth date column equals to. So you are going to use a case when statement. A case when statement is basically like an if statement. So if a certain condition is true, then you do this. If it is false, then this needs to be done. So when the birth date, and then we'll use the like operator. So in the birth date, like this pattern. So if the birth date, it has a forward slash in it. So basically this percentage sign, what it means is that the forward slash, there are characters before it and there are characters after it. So if the birth date value has a forward slash, then we are going to convert it from a string to date. So we'll convert it from a string to date, and then it takes in the birth date column, and also you specify the format in which it has been saved. So our birth date has been saved as the month being first, the day, and then the year. So we'll do M and then D, and then don't forget the /%y. So you have to put it in quotes because it is like it's a string value. So birth date. So this will convert the birth date from a text to a date. And then now to put it in the correct format, we are going to use the date format function. So we use the date format function and we enclose it around the string to date. Don't know why that disappeared. It will convert it to the format that we want. So for now, I want it to be in the default Excel format, which is the year hyphen and then the month hyphen and then the day. And then we also do the same for those with the hyphen. So when birth date, like, so there's no point to just typing the whole thing again. So you can just copy this part and then change the / to hyphens. So you paste it and then you change this to hyphens. So remember, inside the string to date function, you have to put it, you specify the date in the format that it is in the data, and then you change it to the format that you want inside the date format function. So we do that. So if it is neither of these, you just set it to null. And then end. Yeah, so that's it for this. So when you run this, it should update our dates. So it seems there's an error down here. It says you're using a safe update mode. So apparently we've been restricted from updating this. So to get around that, this is just for security reasons. So to get around that, we'll use this code set SQL safe updates is equals to 0. This means we are turning off that security feature, so it is going to allow us to update our data. So anytime we are doing our cleaning and we want to update anything in our database, we have to make sure that SQL safe updates is equals to 0. But as soon as you're done with all your updating, you need to change it back to 1 because it is a security feature that's protecting your database. So we'll run that first, and then after that, now we can run our update code. So when you run that, it has accepted. So we're just going to look at our birth date again just to confirm that we've done it right. So select birth date from HR. Yeah, so you can see it has successfully converted the birth date for us. So all our dates, they have been, our birth date values have been converted from a text to a standard date format. So the next thing after that, now you're going to change now the data type of the birth date column itself, because the column itself, it has still been stored as a text data type, and yet it is holding date values. So we need to change that. So I'll just come up here, and then to change that, we are going to alter our table, which is HR, and then you're going to modify the column birth date, then give it the date data type. You don't forget the semicolon. Then you're going to run this. So just to confirm that change, when I come back up here and select describe HR and run it, you can see our birth date has been converted from a text to a date. Yeah, so that has run successfully. So instead of writing this code again, you're just going to copy and paste because it's the same exact thing. The thing you're going to change is the column name. So instead of birth date, you're going to select the hire date. So we're going to replace it in all of them. This should work. So when we run that, let me just bring up the output. It has updated successfully. So we can just confirm that change by selecting the hire date from HR. Let me just show you how the term date values look like. So when you select the term date from HR, you can see here that the term date, it has been stored as a date together with the time value. So we don't need the timestamp because it's not adding any value in our analysis. So you can see it's the date, it's in the correct format, but now it has been stored along with the time. So this is more like a timestamp or date time data type, and you want to change it from that to a date. But now in SQL, it has been recognized as a text, which means not all values were put in form of a date. Some of them are text. So we are going to change that. So to change that, we are going to update our table HR, and then we set the term date is equals to, we use the date function to convert it to date. So it will be equal to date, and then we use the string to date function to convert it from a text to a date. So as usual, we'll put in the term date, and then we'll put in the format that it has been stored in. So it has been stored as a year, then hyphen, then percent month, then hyphen, then percent day. So don't forget the quotes, otherwise you'll get an error. Oh, and it also has the time. So the time aspect will present it as it's, let's see, it's an hour, a minute, and a second. So hour is H, then the colon, you have to put it exactly how it is in your data. Then the minute is, you would expect it being represented by an M, but it's actually represented by an I because M is already being used for month, so you cannot again use it for time. So, and then the second, so it'll be another percentage, and then S, and then UTC, because that's how it's been stored. So you have to write it exactly how it is. And then for the term date values, we update it where the term date is not null. So where there is not an empty date value, we have to update that, and also it's not an empty string. So we're just going to use set here a condition where term date is not null and the term date is not equal to an empty string. So an empty string, you just basically put quotes and a space. So when we run that, and then we select term date from HR, the employees who are still working in the company, their term date has been set to 00 instead of being blank. And then there's for those employees who have been terminated, the time aspect has been removed from the date. So now it's just the date that is there. We're going to do as we did earlier. We alter our table HR, and then we'll modify the column. Term date, and we set it to the date data type. So we'll run that. So yeah, it has run successfully. Yeah, so we are just going to run they describe a chart to confirm that we've converted all our columns to the correct data type. So if I bring this up, we can see the birth date has been converted to date. The hire date is still in text, so we are going to check. And then the term date has been converted to date. So when you go back to where we wrote the values to update the hire date, so we forgot to alter the hire date to a date. So we'll just copy that. Then you are going to convert the column itself. So here we just put hire underscore date, and then we run that. Then when we refresh, it should be showing correctly. So you refresh all. Yeah, and the hire date has now been converted into a date column. So we can just confirm that. Yeah, so you can see hire date has also been converted from text to date, as well as the term date. So for the rest of these columns that have the text data type, if you want, you can convert them into varchar, then you specify the number of characters you want. But for me, it doesn't really make any difference. As long as it's text, it's the correct data type. Yeah, and one thing I forgot to mention is that in SQL, these keywords, they don't have to be capitalized because SQL is not case sensitive. So even if I used small letters, it will still work. But we're using the uppercase because it's just best practice. So when you're writing code, it's usually better when you're using the best practices. So the next thing we're going to do is find outliers in our data. So when you display all our columns, we need to check for columns like the birth date. So the birth date, the way we are going to go about it is I'm going to add an age column just to make it easier to work with, because if I start doing the subtracting current date, birth date, and all that in every query, it's going to slow down our queries and it's just not a good practice. So we're going to add an age column to our data set. So we're going to do an alter table HR, and then you add column will be called, our column will be called age, and then the data type will be int. Yeah, so when you run that, and then we select all from HR, we'll be able to see whether the age column has been added. So if I scroll to the side, to the very end, you can see the age column has been added, but it has no values because we are yet to calculate the age. So to calculate the age, we're going to update our table. So we update HR, and then we set the age column equals to, so we're going to use a function called the timestamp diff. So that's basically, it calculates the difference between the current date and the birth date. So timestamp diff, and then inside we want to calculate it with the year. So our date, obviously, it constitutes of the year, the month, and the day. So we just wanted to use the year section of it, and then we'll select the column that you want it to use, which is the birth date, and then we want it to be subtracted from the current date. So we'll use the date function. Yeah, and then we'll add another column to enclose that. Then you don't forget the colon. So when we run this, it should update our date, our age column with the correct ages. So let's just confirm that. So we'll select birth date and age from HR. So when you see, you can see it has calculated the difference. So it has taken the current date, which is 2023, minus each of the years in the birth date. Yeah, so as you can see, even just as I've scrolled a bit here, you can see there's someone whose birth date is 2066. So that's obviously wrong. So the next thing you're going to do is you're just going to check for those outliers. So you're going to look at the minimum age and the maximum age so that you can see the employees in our data set, they fall between which range. So you're going to do a select, and then we do use the min function. So you select minimum of the age column, and then we alias it as youngest. You put a comma, then we'll do the maximum of the age column, and then we alias it as oldest from our table, which is HR. And then when you run that, you can see the youngest is -46 and the oldest is 57. So obviously there are a lot of values here which are wrong. So we are going to select and see how many records in our data set have a value which is less than 0, or rather less than 18, because that makes more sense. So we're going to do a select, and then we'll count. And then we'll count all the values from HR, all the records from HR, where the age column has a value that is less than 18 years old, because that it won't really be useful to us. So we just want to see how many records there are and if we can exclude them. So earlier we saw that our data set, it has over 22,000 rows, so 967 values. You can exclude those when you're doing our analysis. So these are the questions that you're going to be answering for this data set. So I've come up with a list of 11 questions. So at the end of it, if you feel there's something I've left out, you can always add it to your analysis. So we'll start with the gender breakdown of employees in the company. So we'll select the gender, and then the count of all those employees. We label it as count, and then from HR, where remember we want only to include employees whose age is greater than or equal to 18, and also who are currently working in the company. So that means their term date will be equal to 0, because that is how they've been represented here in our data. So when you come here to term date, these zeros are for employees who are currently in the company. So for every query, that is what you're going to do. Group by gender, semicolon, and then you run. So this is the output: the male 8911, female 8019, and conforming for 81. So you're going to save these queries as CSV files, which will later on import into Power BI and use for the visualization. So you come here, you save, and this will be saved as gender. You just save it with a memorable name so that you're able to remember. So what I'm going to do is just copy this whole section, because I don't want to keep typing it again. Actually, just copy this whole section. I don't want to keep typing it because the condition will be the same for most of these queries. So we go on to number 2, the race or ethnicity breakdown. So you'll just select the race and then count all as count, of course, and then from HR. So in SQL, you don't really have to use the capital letters, but it's good just for the consistency, and it's good practice. So we'll do group by race, and this group by, we are using it because in our select we've used an aggregate function. So the column that the aggregate function has not been used on, we have to use the group by statement on it. So we'll group by race, and then I'll order by count because I want it to be arranged such that the race that has the highest number of employees representing it is at the top. So order by count descending. So when we run that, you can see white, they are over 4,000, and then those are the highest, then the lowest are native Hawaiian, who are 952. So again, we'll save this output as race.csv. Yeah. And then number 3 is the age distribution of employees in the company. So for this one, you're first going to find out the minimum age and the maximum age of employees who are currently in the company. So we are going to do select, then you do age, minimum, age, then you label it as youngest because you want to see the upper and lower limits, as oldest. So for oldest will be max, not min. And don't forget a comma here. Max, age as oldest, all of this will be selecting it from HR, and then of course we paste in our condition, put the semicolon, then when we run it, the youngest is 20 and the oldest is 57. So with this information, we're going to now create the age group so that we can see which age group has the highest number of employees and which one has the lowest. So to create these age groups, we'll use a case when statement. So we'll do a select and then case statement. So we'll do when the age is greater than or equal to 18 and age. So for me, these are my age groups. If you want, you can change yours. Age group is less than or equal to 24. Then that age group will be called 18 to 24. You have to put it in quotes. So we'll copy this. So we'll come back and copy our condition after we're done with this. So here it will be 25 to 34. To 34, and then you paste it again down here because I have about 6. So this will be 35 to 44, then 35 to 44. So a case when statement is basically like an if. So if this condition is true, then this should happen. If it is not, this other thing should happen. So that is basically just how a case when statement works. To 54. Then for my second last one will be 55, and this is 64. So if you're not in any of these, else it will be 65 plus. Don't forget the quotes, and then you go to end. As I'll call it, this column will be called age group, and then the other columns will be the count. All it will be called as count. Then all of this will be from the HR table, and then come back here and copy our condition because we'll use it a lot from HR, where the age is that and the term date. So we want only the current employees in the company, so we group by age group, and then we also order by age group. Then you put the colon. So these are our age groups. There is 18 to 24, there's 44 to 54, 64. So we should have, because the oldest is actually 57, so we need to have well, it seems like those who are above 57, they're not hired. Or maybe I made an error somewhere. Let's see. Age. Oh, I labeled it 15, so it is 55. Yeah, so be careful when you're writing. Actually, you'll get the wrong result. So when you run it again, yeah, because you're supposed to have the 5 up to, because the oldest is 57, so this category 55 to 64 should also appear. So that is correct. So you're going to save our query. You're going to save it as agegroup.csv. So you save it, and then I'm also curious about how the how the gender is distributed among the age group. So for this, we'll just do the same query, but now we'll add the gender to the column. So we'll just copy all of it and paste it just right below, and then we'll add gender. So for here, end as age group or as count. Then we'll also select gender. No, I want gender to come after age group. So you'll delete that, you put gender here, and then you group by gender, then you also order by gender. So when we run this, you can see 18 to 24 female is 1009, male is 1134, and confirming is 55. So this is exactly what I wanted. So we'll save this as age group gender. Use descriptive names, because in Power BI you'll be able to remember what it represents. So for number 4, how many employees work at headquarters versus the location. So we'll select the location, and then you count all as count. So all of this from HR, and then our condition. So we come back up here and we copy this condition. That is our condition, because we want only for employees who are currently in the company. So we group by location. Yeah, so we run that. Headquarters is that and that. So we save it as location.csv. So you save it and then just add some space here. So next up we'll come to number 5, the average length of employment for employees who have been terminated. So for this, we want to see like how long were the employees working in the company before they were fired or they quit, or whatever the case was. So we'll do a select, and then we'll use the datediff function. So this datediff function, it calculates the difference between two dates. So for this, you want the difference between the term date and the hire date. So it calculates the difference between those, and the output is given as in days. So we'll have to divide by 365 for us to be able to get it in years. So because this is the average, you're going to use the average function. So we do avg, we enclose all of it as the average, then we divide by 365 to get the number of years. So all of this will save it as average length of employment. I know it's long, you can give it a shorter name. So all of this, we do it from HR, and then where, because these are those who have been terminated, so their term date it has to be less than or equal to the current date, and also it cannot be someone who is currently working in the company. So the term date should not be equal to this 0. Yeah, and also they have to be above 18 years old. So the SQL, you have to really think about the logic, because even if you use the wrong logic, still it will give you results, and sometimes it's hard to determine if they are the correct results. So for the average length of employment for employees who have been terminated, we calculate the difference between the term date and the hire date. So it should be the term date minus hire date. Using this datediff function, it gives us the total number of days since they were hired to the date they were terminated. Then we divide by 365 to get it in years. Yeah, and then now we filter out. We only want employees who have been terminated. So that means the termination date has to be before the current date, and it also can't be any employee who is currently employed. So the term date cannot be equal to those many zeros. So after you write that, you'll run. It will give us decimal places. So if these decimal places, you can reduce them. So mine, I'll just do 0 just to keep things simple. So I'll round, then 0 decimal places. So when I run this again, the average length of employment for most employees who've been terminated is, most of them work for at least 7 years. So I'll save it as avg underscore length underscore employment, because typically most companies, they just don't want to keep training you, investing in you, and then you just leave like after 2 or 3 years. That's a loss on the part of the company. Anyway, for the next one is the gender distribution vary across departments and job titles. So we'll select the department, then we also select the gender, then of course the count as count, and then from HR. So we'll again go up and copy our condition. It's going to apply here because we only want current employees who are above 18 years old. So you paste it in there where the age is greater than 18 and all that. So group by department and gender, and then you order by the department. Want to see distribution across each department. So when you run that, accounting female is 1175, male is 1375. So it seems males are slightly dominant in most of these cases. So we are going to save this as gender department. So that will help me remember. Gender departments.csv. So the next question is number 7, the distribution of job titles across the company. So I will select, so it's job title, and then count all as count, from HR, then our condition, we want only current employees, so you group by the job title, and then you order by job title descending. You just want to see how the job titles are distributed in the company. So when you run that, you can see here, for example, there is web developer 1, 2, 3, 4, and all that. So when you give this to the HR manager, they'll be able to know whether all those web developers 1, 2, 3, and 4 are really necessary, or there maybe 1 and 2 can do the job for all of them. So anyway, you save that as job title. Then number 8, the department, the highest turnover rate. So turnover rate basically means the rate at which employees leave a company. So That means like how long do employees work in a company before they leave or they quit or are fired. So for this, we're going to use a subquery because there'll be some sort of calculation. So to get this turnover rate, you calculate the total number of employees who have left over a given period divided by the total number of employees that were in the department during that same time period. So we're going to use a subquery. So for our outer query, this is where I'll define the columns that you're going to have. So I'll select the department, and then I'll also select, I'll have a column called total. I'll have a column called total count, which is the total count of employees in the department at the time. So also the terminated count, and then I'll also have the termination rate. So termination rate will be calculated as the terminated count divided by the total count. So with that, we'll be able to get the termination rate. So I'll save this as termination rate. So this termination rate, all these columns, they're going to be calculated inside the subquery. So all of this you select from. Now the subquery comes in here. So we are going to do select again. We select the very same columns, department, and then we'll do a count of everything as total count. So you can see the columns we defined in the outer query, we are now defining them here inside the subquery. And then the next thing we are going to do is the total number of, we'll use a case when statement to find the terminated count. So obviously those who are terminated, their term date is not equal to 0, because those term dates equal to 0 are for those who are currently working in the company, and also their term date is less than or equal to the current date, because someone can actually be terminated today. So that will also be a valid termination. So the term date has to be less than the current date, can't be equal to 0. So if it meets these conditions, then that employee is counted, otherwise they are not. So you don't forget the end. All of this you select from HR, and then our condition. So where the age is greater than or equal to 18. So here I don't think we need to put that term date, because you are calculating the employees who've been terminated. So here will only, our condition will only include the age. So and then you group by department, and then that's the end of our subquery. So we're just going to close it and give it a name. So I'll just call it subquery to keep it simple, but you can give it any other name. And then for outer query, we will order by the termination rate, but descending because I want to see which department has the highest termination rate. Terminated count in the field list. Oh, here at end we did not give this a name, so this will be as terminated underscore count. Yeah, so our query has become very long, so we just run that and it shows us. So auditing has the highest termination rate, followed by legal, and then the lowest termination rate is in marketing. So we'll save this query as turnover rate underscore rate.csv. You save it, and then now we'll come to the next, number 9, the distribution of employees across locations by city and state. So for this, I'll just use the state because the cities, they're so many cities, and I think when you plot them on the map they'll be really congested. So I'll just use the location state. Select the location state and obviously the count of employees as count, and then you select all of this from HR, and then our condition. So let me just find it. Because we want for the employees who are currently working in the company, and then you group by location state. Location state, and then order by the count. I want to see which state has the highest number of employees. So Ohio State is the highest, then Wisconsin is the lowest. So for this one, we'll save it as location. Oh, I'll save this as state. This is the distribution across states. So this is, you save it as state. Then number 10, how has the employee count changed over time based on hire and term date? So we want to see for this data, it is data from the year 2000 to 2020. So you want to see, for example, for the year 2000, how many employees were hired, how many were terminated, and what was the percentage change, so that we can know whether it is increasing or decreasing as the years go by. So for this, we'll also use a subquery. So our outer query will have the year. So we'll just select year, and then you'll have hires, then terminations, because this query is going to have a lot of calculations, so it will not look good when you have a lot of calculation inside your query. It will actually confuse you. So the net change will be equal to hires minus termination. So this is what I'll call my net change, and then my net percentage change will be the net change, obviously, over the number of hires times 100. So I'm just going to copy this and paste it here. Divide by the hires, and then this, we'll put it in brackets. Divide by hires. No, this is what will be in brackets. The hires minus termination will be in brackets. Divide by the hires times 100. Yeah, times 100, and then because it will be a percentage, obviously there's going to be decimal places, so we just use the round function to specify how many decimal places we want. So this, I want it to have at least 2 decimal places. Yeah, so this will be called as net underscore change underscore %. So it shows me there's an error. Oh, it's the comma as net change %. So this is our outer query, and all of this, you're going to select it from now our subquery, which we're going to create just now. So it will be select the same. So I'll use the year function to get the year from the hire date, because that is what we're interested in. We're interested in the year part of the hire date. Then this is what we'll call the year column that we've already. So I'm just going to indent as year, and then the number of hires. So the number of hires is the total number of employees in that department at that time. So as hires. Then next we'll define the termination. So by now you already know this, so it will be sum. Then you use a case when statement. When the term dates, the terminations, your term date cannot be equal to 0 because those are employees who are currently in the company, and your term date also has to be less than or equal to the current date. Yeah, then if you meet these conditions, you'll be counted, else it will be a 0, then you end, and this will be called as terminations. All of this, we select this from HR, and then our condition where age, you have to be older than 8, you should be 18 years and above, and then you group by the year, hire date. Yeah, so this is our subquery, so we are going to close it, and again I'll call it subquery just to keep things simple, but you can call it any other name. Then for the outer query, we're going to order by the year ascending, because we want to see from the earliest year to the latest. So the net percentage change in 2000, there was 87%, 2001 was 81%. Now when you come to 2020, it's up until 98%. So obviously the employee count has been increasing. So for our last question is the tenure distribution for each department. This is basically just how long employees stay in each department before they quit or are fired or something of the sort. So we want to find the average, like how many years on average do people stay in one specific department. So we're going to select the department, and then you'll again use the datediff function because it's the difference between the term date and the hire date. But of course it will give us in days, so you have to convert it. You divide it by 1000 by 365, I mean, so that you can convert it into a year. And because you are finding the average, this will be AVG. Enclose that in AVG, and then obviously it will be a decimal point, so you're going to round it off to 0 decimal places. That's how I prefer. If you want it to have 2 or 1, however you want, you can use that there. And then this will be called as the average tenure. I'm not sure how that's pronounced. Then all of this you select from HR. Then of course where the term date is less than or equal to the current date, because these are people who've already left the company. And then the term date also, it cannot be equal to 0 because those will be employees who are still in the company. And you also have to be above 18 years and above, and the age is greater than or equal to 18. So we group by department. Group by department. So when we run this, average tenure, you can see most of them are 8, 7 years, some are 6. So we are going to save this as average tenure. Yeah, so we save that. There is one I'm not sure whether we've saved, the number 10, where it's the employee change. Yeah, I don't think you have saved that. So we are going to run this again and you save that query. Yeah, this is the net change. You save it as CSV. So I'll save it as employee underscore change dot csv. So we saved it. So that was the end of the questions that I had for us to answer. If you have any more questions you can think of, just you can include them. So now we are going to use the CSV files you have saved to visualize our data in Power BI. So the first thing we do when creating a visualization in Power BI is just to create the title for our report. So I'll leave a space here because there's a card that will be put there later on. So I'll just call this HR Employee Distribution Report. Or you can just give it any title that you feel is suitable for it. I'll select all of it. I'll put a font size of about 28. Then it's times, I love Times New Roman. So, and then you'll center it. And then here on the right, under effects, we'll change the background color. So I'll do a blue, and then the font color will be white so that it's visible. Yeah, so I think that's good enough. So the first thing we're going to do is we go to home, get data, and import our first CSV file. So you can't actually import all of them at once. So I'll start with average length of employment. So it will load it in, and then it will appear here on the data pane, on this data view. So you click on load, and then it appears on this side of data, and then we'll just add our card. So for each visualization, we'll try to format it a bit as we go on. So I'll add, so it has come in, so I select the card, I reduce it, and then I squeeze it here on the side. Yeah, and then you expand this and you select that, so that is where it's going to appear. So you come here to format your visual. So category label, we turn it off. Then we go to general, we turn the title on, expand it, and then you write this is the average length of employment. In brackets, you write years, and then you make it bold and you center it, and then you can increase the font. Yeah, you can reduce it, and then visual. On the callout value, you can change the color from black. I'll change it to the blue that I'm currently using. So we'll go to our next one, which will be the gender file. So here we'll put a chart. It will be for the gender we'll use a bar chart. So I'll just use this stacked column chart, and then I'll select gender. So gender will go to the x-axis, count to the y-axis. So this is good enough, so I'll just expand it a bit. I go to format my visual, I'll add data labels, and then the position is on top. That's good. The values, we'll make them bold and increase them. Yeah, and then the y-axis, you're going to turn it off. And then for the title, you go to title, you change the y-axis is going to be number of employees. Yeah, then you come to general, select title, you change the title. So Control A, and then it will be the gender distribution, or whichever title you feel goes best. That will be gender distribution. Then you come back to visual, and then you'll go to columns. That is where the color of the bars will be changed from, and you select, and then you go back to general for the title, and then you make sure you center align it. Yeah, so and then for the come back here for the x-axis, we're just going to turn off the title because it's explanatory from the title up here. So we'll just come back here and increase the font of the title. Yeah, so that's good enough. So next we're going to do location. So you get data, text, or CSV. You do location. You want to see how many are remote and how many are headquarters. So you load it in. For this, I'm going to use a donut chart to show the proportions. So I click on donut chart. So in Power BI, you make sure before you select your next visual, there's no visual that has been selected on your report. So I'll select location, count, and location. So I'll come again, format my visuals for the slices. For the headquarters, I want it to be gray. And then for remote, it will be that blue. Yeah, the legend, probably increase the size a bit. And then general, we'll go to the title. So we do employees. Let's do headquarters versus remote. Versus remote. And then of course you're going to center it and increase that a bit. So next you're going to do the change in employee. So we go to employee change, we open, then this will be a line chart. So we load it in. So after we load it in, we're going to select the line chart. We collapse this, so employee change. So the year will be on the x-axis, the net change percentage on the y-axis. So we select this and put it here, just next to our donut chart. And then you format the visual. Of course, the line, you change the color, you go to line colors, you change the color to the blue that you want, you turn on the markers. Yeah, so for the x-axis, we are going to turn off the title, because when you look at it, you can tell that it's the year. And then for the y-axis, the title will change it to the percentage change in employees. Yeah, make it bold. Then you go to general and change the overall title. So Control A. So this is change in employees. Change in employee number from 2000 to 2020. So you can see that generally there's an increase. And then the next one will be the states. So we'll plot a map of the states and how they are distributed. So you'll select states, you select open. So that looks good. You load it in. So after it's loaded in, we'll select this map. Yeah, that's exactly I want it to go to the bottom. Then you expand state and you select count and location states. Yeah, and then you come here to format your visual. The bubbles, you're going to increase the size. That's too big. It's a bit. I don't want them touching each other. So you just reduce until you get the perfect size. Then map settings, I'll select the grayscale. not the road. Then you go back to bubbles, you go to colors, then you select our theme color. That's the color you want. And then the category labels, you put them on, you expand that. The value color of the values, I want it black. Then for the background, I don't want it to have any background. And then I make this bold and increase the font a bit. Yeah, so I think that looks better. And then you come to general and you change the title. Employees by state. Yeah, so we need to center that. So you come back here to general title, and then you align it to the center. So the next one, for the last one for this page, will be the race distribution. So text or CSV, then you come down to race. So you load it in. For this, we'll again use the clustered column chart. So you select this clustered column chart, you expand it all the way to the end. The rest is in x-axis, the count is in y-axis. Yeah, we come to format visual, you go to general, title, Control A, we do race distribution. Then of course you will increase the size, and then you'll center it. And then you go back to visual, the data labels are on, the columns, we'll do the color, our color blue. And then for the data labels, we want to change the position to be on the inside end. So you select values, you make them bold and increase the size a bit. So for the x-axis, you're going to turn off the title because it's in the other one. Then for the y-axis, you're going to turn it off. And then for the title, we'll do number of employees. For each race. So that's good enough for page 1. So we'll go to page 2. And then for page 2, we'll start with the age group. So text or CSV, we do age group distribution. I'll put this one at the bottom. So it's loading. When it loads successfully, I'll use this stacked column chart. So I'll put this one here at the bottom. Age group distribution. So expand age group. Age group is on the x-axis. The count is on the y-axis. So by now you know how to edit this. So you change the colors. That will be that blue. And then for the age group, you click on these 3 dots and then you'll sort axis by age group. You click it again, you sort by ascending. So it's 18 to 24, 25 to 34, and so on. So you come here to general, you change the title, age group distribution. Of course, you increase the font, and then you center it, and then you come back to visual, and then for the y-axis, we turn it off, and then the title will be number of employees. Title will be number of employees. You minimize that, then you go to data labels, you turn it on, and then the position will be on the inside end. And then for the values, you make them bold and you increase the font. And then you'll just make it a bit small, so that's good. So you go again, the age, you want the age group distribution by gender, so you select that. Everything looks good, so you load it in. And then for this one we'll use a clustered column chart because it has the categories by the gender. So you'll select this clustered column chart, and then age group will be x-axis, count will be y-axis, and then gender will be on the legend. So you format the visual, the columns. The female, I want it to be dark, then the male will be light, and conforming will stay orange. Then again we sort this, so you sort axis by age group, you click on the three dots again, you sort axis by sort descending, so it's 18 to 24 and so on. So after that we'll change the y-axis, so we'll turn off, oh no, yeah, we'll turn it off. And then for the title we'll do count of employees. Count of employees, age group, then you go to general, you change the title. So the title for this will be the age distribution by gender. We'll increase that font and then we'll center it, so this looks good enough. Oh, and then visual, we do the data labels. I just love the data labels on top. So position, the position is okay. We increase the values, so we make them bold, and we increase, so the position should be outside end. So I'll just increase this. Yeah, so I think that's good enough for that. And then we have two CSVs remaining. So this next CSV will be the departments by termination rate. So we'll turn over it. This will be a table. So for this table we'll have the department and the termination rate that it has. So after loading it in, we select the table visual. Yeah, that's exactly where I want it. So I want the department and the termination rate. So we'll go here to format visual. Then the column headers, we'll make them bold and increase the font a bit up to there. Then the values, we also increase the font of the values to fill the space. Then for this, we'll also, the totals, will turn off the totals because we don't actually need it. So come here to totals, values, you turn off. So what you're going to do next is come to these three dots and then you sort by the termination rate. So auditing is the highest and so on. And then marketing and business development are the lowest. So yeah, this table will be there. Then you come now to our last CSV file, which will be the gender distribution by department. So you select gender depth CSV. And then this will also be a clustered column chart. So you load it in. Because it has the gender categories, we'll use the clustered column chart. So we'll just expand this. And then it's called gender depth. So the department will be on the x-axis the count on the y-axis, then the gender will be on the legend. So you come here to format visual, the columns, change colors. This will be dark blue for female. For male will be a light blue, non-conforming will remain orange. And then for this x-axis, we don't need that title, so we'll remove it. And then for the y-axis, our title, we'll change the name of our title, so it will be employee number. No, it will be number of employees. And then you go to general and you change the general title, so it will be the gender distribution by department. So this one will it up a bit. Yeah, so it looks good so far. So if there's anything else you feel you want to change based on your personal preference, you can change it, but this for me is good enough. Yeah, so I'll show you how to save. You just come here to file, you click on save as, and then our file will be called HR employee report. So I'll just call it HR employee report. And then you save it. And then you can also export it as a PDF file which you can share with someone else. So I'll come here, file, you export, then export to PDF. So when it's done exporting, when you send it to someone as a PDF, this is how it's going to look. If there's not something you don't like, you can always go back and change. So I'll just save this as HR employee report. Then you save it. So this is how my report looks like. You can add or change things however you like. So the last thing I'll do is just show you how you can save your files in GitHub. So you'll just sign in to GitHub, then you open your repository and you come here to add file and you select on upload files. So when you select on upload files, you'll come here to where you've saved your files. So for example, this data cleaning one, I'll just drag it in here, the data cleaning, and then also this data questions. You just drag it in there, and then this will be SQL queries. And then you commit the changes. So after that, you can also upload your PDF file and all that, and then you'll add a readme file. You just take a screenshot of your dashboard and you put it here. Then you explain the data used, the cleaning, what you used, and then the questions you answered, the summary of your findings, then your limitations. For example, the ages we used, we only used 18 and above, and then the term dates, we did not use the term dates in the future. So those were some of the limitations. And then you can also add a section for recommendations. So if this was an analysis for a certain company, and then you tell them that I recommend you to do this and this with regards to the analysis that I've done for you. So that is the end of this project. Please subscribe and share and like this video, and I'll see you guys in the next portfolio project.